Hi, doing notes on Chapter 12, which is Quadratic Relations. I think the chapter is kind of fun, actually, but it's a tougher chapter, kind of like Chapter 6. So make sure you watch the notes, pay careful attention. If you start getting behind, let me know. I can help you. We're going to start in Chapter 12, Section 1 on parabolas. And you did parabolas 2 chapters before, both Chapter 2 and Chapter 6. And every time that we had that, we had parabolas that either, that's a bad drawing, parabolas that either opened up or opened down. They always were symmetrical about a vertical line, and typically they were centered at the origin, at least in Chapter 2. Then we were kind of moving around that vertex, that low spot. Now we're going to take and we're going to have parabolas sometimes that are going to be off on the side. The equations are going to be tougher for things like that, but we're going to get into really a little bit more about what is a parabola and so on. So kind of the definition of a parabola is, you could say, given a line, like the line I have drawn down below. Now I'm going to put in parentheses the name of that line. It's called the directrix, which is just the word direct with a R-I-X at the end of it. So given the directrix and a point F, and we call that point F the focus. So given a line and a point, a parabola is the set of all points in a plane that are the same distance from the point, that being the focus, and the line being the directrix. So that's our definition of a parabola. Now I want to take my two and move them down a little bit further to give myself some space. If you wanted to, you could label them. You could put in here that this is the focus, and you don't have to read the whole thing again, but that's the focus of our parabola. And then the line here is going to be the directrix. So you're going to get questions that ask you to go through and actually draw in the parabola given a focus and a directrix. And for that, what I usually do is take my pencil and just kind of hover in there. So if I would say, like, this, is this a point? No. This point's too close to the directrix, and you always do the shortest distance of the directrix, not close enough to the focus. So if I move up a little bit more, right about there, kind of right between the two, that's going to be 1 point. And if you kind of go off on the side here, so again, I'm too close to the focus, so if you kind of move away from there, something like that, looks like that's about equidistant. If I go over here, that's looking like that's pretty much equidistant. And kind of what I'm getting for these points is, here's kind of what I'm trying to do, is I'm trying to say that, well, this red line here should be the same as this red line there, kind of going straight to my directrix. Or maybe pick a different color. This blue line here should be the same length as this blue line here. This looks like I'm a little bit high. This black dot here probably should be a little bit lower, so I'll at least make that dot a little bit lower. So something like that. Looks like that ended up being a little bit closer to actually being the same distance from the two. Or if I were to have this line here, that should be the same distance as that line there. Kind of the nice straight shot and nice right angle going to my directrix. So that's kind of what we're talking about as far as getting these points on a parabola. And then once we have those, you could take and just try to draw a smooth curve through them. Redraw that one because I was a little high. But I could get some on the other side also, so maybe a spot right about there, spot right about here. Often I have people that they'll go through and they'll do nice dots like this, and then when they get to the end of it, instead of just going a tiny bit further and stopping, they'll just like whoosh, extend their parabola up and then get points that are like horribly off. So I would encourage you, as you draw this thing, to just go try to get a smooth curve through the points you found, and then quit. Don't go and extend that way up if you haven't found points up there. That just gets risky, that you're going to end up with points that aren't actually on your parabola. So something like that would be a decently drawn parabola, I'd like to say. But something like that would be a parabola, kind of using the definition of a parabola. Now this parabola isn't vertical. Its axis of symmetry is going to be running on an angle. So equation-wise, it's going to be awful. So as we go through and do equations and so on, then we're still going to have parabolas that the directrix is going to be a horizontal line, and it'll open nicely up or nicely down, not off to the side. But moving on then, equations for parabolas. I'm putting my writing here in red for dramatic emphasis. But when we have that, I get rid of my little blue line. There we go. When we have that equation for a parabola, it's going to be same as always, y equals ax squared. And that's at least going to be for a parabola whose vertex is at the origin. And by vertex, we're talking about that lowest spot. So like right here, kind of the straight shot between the focus and the directrix. That would be your vertex. So this would be a parabola centered at the origin. And the focus now is going to be that point. So if it's the point, and the point then is going to be, I probably should draw this out. What I'm really trying to say is this. If I have a graph, we're looking at a parabola now that's either going to open up or open down. And its vertex is going to be centered at the origin. So if its vertex is there, it's going to look maybe something like this and something like that. So we'd have the vertex would be there. The focus would be my point up here. Now I need to be a little careful now that I talked about how to draw it. But then the directrix would be a horizontal line kind of down here-ish. Looks like it should be a little bit higher because the directrix has to be as far below the vertex as the focus is above, so maybe something like that. That's kind of what I'm trying to say, is if we have a parabola like this, the equation will be y equals ax squared, centered at the origin. Now the focus is always going to be on the y-axis, so I could put in a 0 for x, and now the y value is going to be 1 over 4a. So you take that letter a there, whatever numbers before the x squared, you pop it in there, you could get your focus. The directrix is going to be a line, and it's a horizontal line at that. So horizontal lines, they're all the same distance down from my x-axis. So the equation then has to be y equals something. All the y values are in common. And it's real similar to our focus point there. If the focus is up a certain distance from the vertex, the directrix has to be that same distance down. So it's going to end up being y equals negative 1 over 4a. Those equations are real important. If you go to the Moodle site, you'll see I have like a index card link there to a PDF. I probably passed out an index card in class, a large one, where you can start writing down equations for this chapter, because we're going to have a bunch of them. So I'd write down these 3 equations, maybe write parabola up above it. And if I haven't given you the paper, somebody remind me in class tomorrow. We're going to move on, do a few examples. So my first example is I'm going to say, given a parabola with the equation y equals 2x squared, find the focus and the directrix. So thinking back to earlier stuff with a parabola, we have this positive 2, so it's going to be opening upward. We said that positive people smile more, so you can kind of look at it like, you know, they're opening up. It's a smiley face. It's going to be centered at the origin. Our vertex then is going to be at the origin. So really it's saying kind of what's a picture like this. Well, to do that, I'll maybe write this underneath there. Probably not really necessary, but it helps reinforce that the a value is 2. If I want to find my focus, that's 0, 1 over 4a. And all I do is I take my a value of 2 and I put it in there. Most people would do it all in one step. I'm going to do it in 2 just so I don't lose anybody. And so my focus then is going to be 0, 1 over 8. So that's my focus. Now if you want to find the directrix, you could go back to the directrix equation. This is the long way. We'll give you the shortcut in about 10 seconds. So y equals negative 1 over 4a. You could put the 2 in and all that stuff. But if you think back to what I said a couple times now, focus is as far above the vertex as the directrix is below. Well, if the focus is up 1/8, then we know the directrix has to be down 1/8. So that would totally be a way that you could get it without even having to go back to the equation. If you wanted to do the equation, you could put a 2 in there for a. 4 times 2 also gives you the 8. So that's my first example. My second example then is going to be this here, and let's say, hey, look, we have a parabola with a focus of 0, 7, a directrix of y equals -7, write an equation for the parabola. So if you think about your parabola, the focus is up above the x-axis, so then you know it's going to open upward, because the parabola always kind of curves around the focus. The directrix is as far below the x-axis, so we know it'll be centered at the origin. So if we want the equation for the parabola, all we really need to find is a. Figure out what a is, pop it in there, and you're done. So in order to do that, now you really have two options. You could use this focus, or you could use the directrix. I don't like working with negatives, so I often would use the focus, and the focus is 1 over 4a for my y value. So you could then say 1 over 4a equals 7. And now solving for the variable in the denominator, that's something that's been giving us grief all year long. But the book's way of doing that is says, well, hey, get the variable out of the denominator. Why not? I'm going to multiply by 4a. You could just multiply by a if you wanted to. But if I do this, I'm rid of my fraction. So I'm going to say now I have 1 equals 7 times 4 is 28. So 28a. And then from there I could just say, well, I want to get a by itself, so I divide by 28. And when I do that, those cancel out. So a is 1 over 28. So the equation for a parabola, centered at the origin, opening upward, with the focus up 7 from the origin, and the directrix down 7 from the origin, would be y equals 1 over 28 x squared. Example 3. Now let's say we have a parabola, and I'm just going to do the focus. I want to try to make a point in this one, because it's really kind of the same example as before. But y equals ax squared. Now we're trying to find the focus. So my focus, if you go back to that equation, is 0, 1 over 4a, so that's the point. Now we could take my a, and that a is going to be a -3. So I end up with 1 over 4 times -3, which ends up being a -12 in the denominator. And now that's really the point that I wanted to make. This isn't simplified. It's not proper to have a negative in the bottom of a fraction. That will get you marked down. The proper way to write it, one way to do it, would be to say I have this negative fraction, so I have -1/12. The other way you could put it is put the negative in the top, and so you have -1 over 12. But kind of a rule in math is to always make the denominator as simplified as possible. So don't do it that way. Pick whichever one of those you like more. Most people, I think, go with kind of my preference, which is that right there. So focus 0, -1 over 12. Moving on then to paraboloids. We're pretty much at the end. A paraboloid, just want to make the comment that that's a 3D parabola. So if you take out, from our definition of a parabola, take out all the points in a plane, now you're just going to have a point, the focus. Instead of a line, the directrix, you're actually going to have a plane. And then the paraboloid is going to be all the points that are the same distance from that focus and that plane. But why do they call it a focus? Just wanted to talk about that briefly. Can't help myself being a physics teacher. And why do they make satellite dishes into paraboloids? Why do they have that? Well, in order to get an accurate signal for your TV, if you have satellite TV, you need to get a decent amount of signal from the satellite. So you have satellite up in space. It's called a geosynchronous satellite, that it's staying the same height above the Earth in the same position. So it goes around the Earth as the Earth spins. So it should always be in the same direction, which is why if you look at the satellite dishes in your neighborhood, they're all pointed off in the same direction. Well, if you need to get, say, a 2-foot diameter circle of signal from the satellite to get a clear picture, one way to do it would be to get a sensor that's 2 feet in diameter, which is going to cost more. So what they do instead is they take and they have a metal dish, that's 2 feet in diameter. And then that metal dish, what it's going to do is take signals from the satellite, and it's curved in this paraboloid shape. So when the signal hits this metal dish, which is a lot cheaper to make than a sensor, it's going to reflect off in a certain direction, which ends up being through what we'd call the focus. So then if you have another thing come down and hit over here, when it obeys the law of reflection, it's going to take and reflect and come right back through that focus. And granted, they're going to get stopped by the sensor there, but if you have another one that comes in here, it's going to hit and reflect through the focus. If you have one that comes down in the middle, closer to the middle, it's going to reflect and go back through the focus. So in other words, you could take and have a sensor that's fairly small, so make your sensor about yay big, and then all these signals are all going to hit and come together at that sensor. So you could get a lot of signal having a small sensor. It's a lot cheaper for them to manufacture. That's all we have to talk about for parabolas 12.1.